Okay, so let's have another example for the brine solution. So a tank contains 200 liters of fluid in which 300 grams of salt are dissolved. So brine containing 1 gram of salt per liter is then pumped into the tank at the rate of 4 liters per minute, and the solution mixed well is pumped out at the same rate. So letter A, the number of grams of salt in the tank at any time t in minutes. So basically we are looking for the expression how to determine the number of grams or the amount of salt in terms of grams in the tank at any time t. So let's have first the given. So what is our initial volume? The initial volume of the solution, that is the B sub O, we have that as 200 liters. And let's say A, that is the amount of salt, is equal to, this is 30 grams. Then we pump into the tank another brine solution. So at the rate of E, that is the 4 liters per 4 liters per minute, and the concentration of the salt is let's say that is B. That is the solution, it contains 1 gram, 1 gram of salt. Then the rate of liquid coming out from the tank, that is in terms of, let's say, F, that is equal to, according to the problem, the same rate, that is 4 liters per minute. We don't know the concentration of the salt for this one. It is not given. So from our previous discussion, what is our derived initial equation or initial expression? Okay, that is the differential Q with respect to time. This is I plus F multiplied by Q, that is the amount of salt, divided by the initial volume plus the E times T minus F times T will be equal to the B times E. So again, we have Q as the amount of salt. So we may substitute this given to this our initial equation. So this is the change of rate for the concentration of salt with respect to time, the dq over dt. Plus F is 4. This is multiplied by Q to be divided by our initial volume, that is 200 liters. Plus, by the way, what will be the value of the time t? So these are the initial values, or this given class are initial values. So we assume that is at time is equal to 0. So this is plus the value of E is 4 multiplied by time 0, initial values, minus 4 at time 0 is now equal to the value of B, that is 1 gram, the rate E, that is 4 liters per minute. So we simplify, this is now dq over dt, plus, since these values are 0, we have that as simply 4 over 200 of Q is equal to 4. Or this is dq divided by dt, plus, what is 4 over 200. This is 4 divided by 200. We can have it as over 50, or we can have it as 0.02 of Q is equal to 4. So again, this is a linear differential equation. So we need to determine its solution. So it is already in the standard form. So the standard form for a linear differential equation, that is the dy over dx plus the p of x multiplied by y is equal to the q of x. But again, we may use instead of x or instead of y, I'll be using q, that is the amount of salt, and instead of x, I'll be using t. That's since this is with respect to time. So we may have Okay, what is the equivalent of this p of x? So instead of p of x, I'll be using p of t. Okay, what is the equivalent of p of t from our linear differential equation? That is 0.02. So this is 0.02. Then what's the equivalent of q of x? So q of x, so again, instead of x, this will be q of t. That is simply equal to this constant, the constant 4. Okay, so what is the formula for the solution of a linear differential equation? Again, from our solutions for a linear differential equation, this is the y is equal to 1 divided by the integrating factor or the integral factor of x to be multiplied by the integral of the integral factor I of x multiplied by the q of x, then dx plus the arbitrary constant c. But again, instead of using y or instead of using x, I'll be just using the variables applicable for this example. So again, from this general formula, instead of y, I'll be using q is equal to 1 over the integral factor I sub x, that is I sub t, to be multiplied by the integral of I sub t, multiplied by the q sub t, d sub dt plus the arbitrary constant c. So by the way, what is the equivalent of the integrating factor or integral factor I sub t? This is equal to e raised to the integral of, instead of p of x, I'll be using p of t dt. So we can determine that value. What is the equivalent of p of x? Or again, we are using p of t. That is simply equal to 0.02. So our integrating factor I of t is now equal to e raised to the integral of, this is 0.02 dt. What is the integral of 0.02 dt? That is basically equal to e raised to 0.02 of t. That is the equivalent of our I of t. So I think we are now ready to substitute. Okay, so from this equation, q, so we have q is equal to, this is 1 over our integrating factor, this is e raised to 0.02 of t to be multiplied to the integral of I sub t. I of t, what is the I of t? That is e raised to the integral of e raised to 0.02 of t. From this one, to be multiplied by q of t, or the q of x. That is simply equal to the constant 4 multiplied by dt plus c. Okay, then we are now to simplify. We integrate. This is now q is equal to 1 over, this is e raised to 0.02 of t, to be multiplied by, what is the integral of e raised to 0.02 of t? If you are to recall our integral, the integral of e raised to 0.02 of t is simply equal to e raised to 0.0 of t. This is to be divided by 0.02. Okay, that is the integral of that term. So we'll be having, we may bring out this this constant, 4. So this is 4 to be multiplied by the integral of this term, e raised to 0.02. Its integral is e raised to 0.02 of t divided by 0.02 of 0.02. Okay, plus the arbitrary constant c. Then we now distribute this to both terms. Okay, we have q is now equal to, this is 4e raised to 0.02 of t Okay, to be divided by e raised to 0.02 of t, okay, multiplied by 0.02, okay, plus c. This is divided by e raised to 0.02 of t. Okay, so we may now simplify this equation. So we may cancel this one. Okay, e raised to 0.02 of t. Then what is that value? Okay, I think that is the same as the 200. Okay, 4 divided by 0.02 is equal to 200. Okay, we have now the value of Q. Okay, the Q, or the amount of salt at any time t, is now equal to, this is 200 plus, how do we bring this term to the numerator? All we have to do is change the sign of its exponent. That is c, e raised to negative 0.02 of t. Or we have q of t is now equal to c, e raised to negative 0.02 of t, plus 200. To complete our working equation, we need to determine the value of this constant c. Okay, so we have our equation, the Q of t, the amount of salt at any time t is equal to c, e raised to negative 0.02 of t, plus 200. At time is equal to 0, what is the amount of salt in that tank? That is simply equal to the value of A, the initial amount of salt in the tank. That is equal to 30 grams. Okay, we have the value of A equal to 30 grams. Okay, we are now to substitute to determine the value of C. Okay, the Q of T, or the amount of salt, is 30 grams is equal to C. This is e raised to negative 0.02 at initial time, that is time equal to 0, plus 200. So basically this is 300 less 200, that will be equal to 30 minus 200, that is negative 170, is equal to C. Since this term, e raised to 0 is the same as 1. So we'll be having the value of C, the constant C, is 30 minus 200 is negative 170. Now, if you are to answer the first question, the number of grams of salt in the tank at any time t in minutes, we are looking for the expression. Basically, this is A, the expression or the working equation. This is the Q of T is now equal to, the value of C is negative 170 e raised to negative 0.02 of the time plus 200. So this will be our working equation. The amount of salt in the tank at any given time t. That will be for letter A. Then letter B, the amount of salt in the tank after 5 minutes. So all we have to do is substitute that value in our working equation. So by the way, this is the working equation. For letter B, so we are looking for the amount of the salt at a given time equal to 5 minutes. So we substitute in our working equation. Let's say that is Q of T, and that's Q of 5 is equal to negative 170. This is e raised to negative 0.02 multiplied by the time, 5 minutes, plus 200. We have the Q of 5 is now equal to, this is negative 170, shift E, is negative 0.02, times this 0.02, times the time, 5 minutes. Then plus 200. That is 46.1776. So this is 46.1776 grams. So there will be 46.1776 grams of salt after 5 minutes. Okay, so again, that is for letter B. Okay, so we are now able to answer letter B. So for letter C, the time when the amount of salt in the tank is 50 grams. Okay, that is for letter C. Okay, for letter C, we have the amount of salt is now equal to 50. This is 50 grams. So we are looking for the time. So again, from our working equation, that is the Q of t is equal to negative 170. This is e raised to negative 0.02 of the t plus 200. So this is 50 is now equal to negative 170 e raised to negative 0.02 of the time plus 200. So this will be, what is 50 less 200? That is negative 150 is equal to negative 170 e raised to negative 0.02 of t. Then we divide both sides of the equation by negative 170. So this is that will be positive. 150 divided by, or if you are to reduce that in fraction, so 150 over 170 is 15 over, this is 15 over 17 is now equal to the e raised to negative 0.02 of t. So to bring down that exponent, we are using a natural logarithm. So this will be the ln of 15 over 17 is now equal to the ln of e raised to negative 0.02 times the time t. We bring down this exponent. So this is now the ln of 15 over 17 is equal to negative, we bring down the exponent, negative 0.02 of t. This is the ln of e. And ln of e is 1. We are now dividing both sides of the equation by negative 0.02. So this is divided by negative 0.02. Then computing for the time. So the time is now equal to, that is the same as the ln of 15 over 17 to be divided by negative 0.02. And that will be equal to 6.2582. Let's say 6.2582 minutes. So 6.2582 minutes. Okay, so for letter C, it will take 6.2582 minutes before for the amount of salt in the tank will be equal to 50 grams. So this will be our solution for this example.